Hello, welcome everyone. Thanks for joining. So first about me, there's really three of us that created this slide, so I'm just the messenger. But all mistakes are mine. I've made lots of changes afterwards. So I'm Pedro, I'm from Lisbon. I currently live in Barcelona. I wrote a book in 2019 called Agile Technical Practices Distilled. There's a coupon code. There's a link here if you want to go and grab it. I created a small discount. And the other two that worked with me on this are Alessandro. He also is one of the co-authors of the book. And he lives in London, where I used to live before. And there's also Marco. Feel free to reach to any of us if you have any questions. Our Twitter handles are down there. I'll share them in the end again. So let me start with direction of development. So there's two ways we can develop some application or some system. We can start from the inside and build it towards the outside. So start building, I don't know, the inner details and then go to the more complex details, or you could start on the other way. You could start from the outside and go from the macro to the micro. And this is the direction we are going to talk about today, starting from the outside. Now, there's a mindset in here. So the first thing is starting from the outside and going to the inside. And it's also starting from higher level responsibilities and go to low level details, from the main goals to the steps to reach those goals, from strategical to tactical, and also following the dependency flow. Some of the advantages, it's more focused on the business. So I'm not focusing on the technical details of how I'm implementing something. I'm actually trying to write code to serve a purpose of business, try to drive the growth of the system through behavior. It's quite nice side effect. It tends to avoid Yagni a bit more. For those that are not familiar with Yagni, it's you ain't gonna need it. Because really we are not writing any code that does not serve a purpose of some other code. If I'm starting from the outside, I wrote the most macro code and all the details come as a service to the other code that's most on the outside. It can minimize entropy. It focuses on the interface. It leads to simple design, and I'm always serving the business. Okay, I'm gonna skip. So I'm going to talk about the two main schools of test-driven development. So there's the one that's called Classic and the one that's called the London School. There's several names of these. So if we do the Classic, also known as the Detroit or Chicago School of TDD, how do I write code? How do I approach? I might write a test, and then I implement a class that is the class being tested, and I might implement the method. And the test goes green. I write another test. I write a bit more of implementation. And maybe this time I find out, oh, I need to refactor something. Let me put some parts of what's in there private, for instance, small refactor. And I keep going. I write test 3. I put the implementation here. And then in here, I might see, oh, there's a solid problem in here. I'm breaking single responsibility. Let me refactor part of the implementation into another class. Okay, I'm fairly happy with this. The code doesn't look like to break any solid principles, and it's not breaking any, it doesn't have any design or code smells. So let's continue. I write test 4, again, write the implementation here, get some feedback from code smells, solid principles, all those things. And then I decide, okay, let me extract class 3 over here. And slowly I start designing my code. And in the refactoring phase, I take a lot of design decisions. Now, on the London School, it's a bit of a difference. So I write a test. Again, I put the class. I write the method. It's still not green. Don't pay attention to those things. I couldn't get the keynote to behave. So it's still red. The first thing I am going to do is to find a collaborator. So I'm going to say this class is not taking that responsibility. So I'm looking at design problems in the red. if you look at the previous way we were doing TDD, we were looking at design problems most in the refactoring phase. So we would wait, we would generate a bit of messy code, and from that mess we would get feedback and say, oh, we are breaking single responsibility, we have a code smell in here, let's fix it. When we are doing London School, we need to find the design problems almost in red. And I'm saying, oh, if I write this in here, it's going to generate some problem. So I'm going to find a collaborator to delegate that behavior. Because I don't have enough information, what I use is mocking. And I will mock the collaborator too. And then the test goes green. I write another implementation, and immediately I find who am I going to delegate this to, because this doesn't seem to look to belong in class 1. So let me find some other place to put it. Again, I mock it and I write the test like that. So you can see that I'm doing outside in on both of them. So you can do outside in on classic TDD. You don't need to use the London School, but in the London School, I'm taking the design decisions way early than on a classic TDD. And then I keep going. I write test 3. Finally, I write class 2. I mock again the collaborator. Test 4 for class 3, and I mock again the collaborator. And I keep going like this until I reach the end. At some point, I cannot mock anything more, and I probably need to switch back to the classic school of TDD and assert against state instead of asserting or verifying that the mock was called. But I do that at the last moment, and I'm taking design decisions very early in the process. Okay, so let's move on. So a bit about test levels. I don't know how many of you are really familiar with test levels. I like to compare them with baking cookies. So if I'm baking cookies and I have a oven, I put the raw cookies in a oven, and let's assume this is a class and there's a function called bake. When the cookies are done, I take them out and I assert against the texture of the cookies, maybe the deliciousness of the cookies. I don't know if this is a word or not, I just invented it, but you just test that you get the cookies you expect to be. And this would be asserting against state. I give you raw cookies, I take cooked cookies, and I assert that this transformation has been all right. The raw cookies have transformed themselves into the cookies with the right texture, and they are delicious. Okay, now my business is going really, really well. I'm baking cookies like there's no tomorrow. So I decided to buy a packaging machine. Then suddenly, when I put my cookies on the oven and I bake them, there's no way for me to take them out and test if the baking is good or not. So I need to change my testing strategy. Let's imagine there's like a tray where the cookies roll out of the oven into the package machine, and then I really want to test that the baking operation as being all right. So how can I do this? Where do I put my assertion? And the trick is to use a test double or a mock, conventionally known. And then what I am going to do is I cannot take the cookies out of the oven, and I don't want to open the packages. So I look at the texture and the deliciousness of the cookies as the input of the package. And that's usually when we call, I don't know, in lots of mocking frameworks, you verify that the method was called with certain parameters. Okay, so that's the way we do it. So a red flag for me is when I look at code that has, you verify and then you put any or any argo. There's lots of ways of doing this, because if we are doing this, we're not really verifying that the baking process has gone correctly. That's what I want to test. I want to test that I put the raw cookies and I get the right cookies out with the right texture and the right delicious. If I throw away looking at the parameters, the input, and look, I don't mind, as long as it was called with anything or with any cookie, I'm all right. No, I want the package to have been called with the cookies with the right texture and the right deliciousness, because I'm testing the bake. So for me, this is sort of a red flag. Doesn't mean sometimes I need to use these things. It's more on legacy code. If I'm writing code and I put an any, I think really hard, why am I putting any or something like that? Okay, back. So this was a short intermission. So The next thing I would like to talk about is test boundaries. I think this is quite an important thing when we are talking about test driving code. So assume we have a typical application. Could be a backend application, does not need to be. But for the sake of it, let's say it's a backend application. It has views, it has controllers, some application services or use cases or something like that. Then it has a domain model in the middle, might have some domain services, repositories, a database, an external service being abstracted by a proxy. So how do I test this? Okay, so the first, before that, London School of TDD also talks about a very interesting thing. It's another characteristic of the London School. And this is also present on BDD, although BDD is much bigger than just this. This is just a technical element inside BDD. This would be the double loop TDD, where you write an acceptance test. I like to say you write your definition of done, and you leave that test red, and then you go inside the unit test loops and you keep writing unit tests until eventually your acceptance test becomes green. Okay, we'll talk about what is an acceptance test, speaking about boundaries, which I think it's more interesting because names in testing get very confused. Okay, so test boundaries. So this is how I would define an acceptance test. It would start on the application service, and I would not exercise the outside well, because I want this test to have fast feedback loop. And if I'm executing anything on the database or I'm calling an external service, my feedback loop is not really fast. Even if I use containers or some sort of container to host the database, it's still slow. I still need to do a network call. I still need to do an out of process call. And I want my tests to be fast, even acceptance tests. So I tend to write the acceptance tests within these boundaries. And I prefer to talk about boundaries. I think it's more visual to see this is an acceptance test. Other people might call this an integration test or some other name, a contract. I don't know. There's lots of terminology on testing. So that's why I like to speak on boundaries and test on the boundaries. So I define this boundary and we test at this boundary and we call this the acceptance test. Okay. Of course, if I have external resources, I want to test double them. I want to mock or stop them. Depends on the situation, because like I said before, I want a very fast feedback loop even for my acceptance tests. Okay, so this would be sort of the boundary of an acceptance test. Okay, the next one would be, right, oh, this slide is wrong. An integration test. No, this slide is wrong, sorry. Let's go here, sorry. So this would be an example code for an acceptance test. So if I'm writing acceptance test, remember the boundary. I'm testing at the level of a use case. Depends on how you call it. Some people call it a use case. Some people call it an application service. So it doesn't matter which one it is. This is a game. I just wrote the minimum code. It's like a colossal cave game where you move from one room to the other, and then the game displays and gives you back some tests, and you decide what you want to do next. So I'm testing this, I'm writing this acceptance test so that the player can move in rooms. So I'm exercising move north, move east, move south, move west, and I'm exercising that with two players. So this is sort of a macro behavior, and that's how I see an acceptance test. I'm trying to prove that moving works. Okay, so I'm doing lots of movements. I think this is like a circular movement going around, and then I'm testing that two players are in the same room. Okay, so this would be for me an example of an acceptance test. And if you see, I'm mocking the repositories. I'm not going into exercising the repositories because I want my acceptance tests to be fast. In this case, I'm starving the repositories to be a bit more precise. Okay, let's go to the next test boundary. Okay, so the next one would be, for example, testing a controller. This would be a unit test. I'm testing a controller. And I probably don't want, since I'm only testing the controller, I don't want to run the whole application. The only thing I care about is when I call the controller is doing its thing, which is abstracting the web or the internet or an HTTP call, to be more precise. So what I care to test in a controller is that when I call it with, let's imagine it's some JSON and I post, I want to test that it converts the data it gets from the web into an application data. So that's the only piece I care about. And that's why I test double the other. And I look at the output of the controller as the input of the application service. So think again about the cookies and the packaging. So in this case, the controller would be the oven, and the application service would be the packaging machine. So I still care that the data that comes from the web gets in the right way into the application service. And so I'm testing that the controller is doing its transformation correctly, and the other way around as well. When I need to return data from my application, it gets correctly converted into a web format, maybe JSON or maybe something else. Cool. So this would be unit tests with doubles for the controllers. And this would be an example. So in this case, I'm mocking the app service because I don't care about that. And what I care is the app service was called with the right data. So here, I'm assuming that the controller gets called with an int, which represents maybe a player ID, number 1. And what I care is that the application receives the call to the start method with the data converted to a player ID. And the 1 is still there. So that's what I care. The controller has done its job. It received the primitive type and it translated it into an application type. And that transformation has worked correctly. Okay. So I'm not testing that start was called with any player ID. It was called with the correct player ID because I'm testing the controller and the controller has done its part. Okay. Next thing. So more examples of unit tests. Okay, this could be a unit test. Now, this slide might be a bit more controversial because sometimes people, when I'm discussing unit tests and sometimes doing these boundaries, people get shocked with this and say, why does a unit test include more than one class? I don't see a problem with that. A unit is not a unit of code. It's more a unit of behavior. For me, and I think Kent Beck talks a lot about that. And sometimes we make unit tests too technical and we forget that it's about testing micro behaviors. And if the behavior goes across more than one class, so be it. It's no problem. So this might be a unit test. And if there needs to be test levels, because I still don't want, the only thing I care about in testing is not to go outside of my application and make unnecessary network calls. In this case, I've got a question mark on domain services. It depends on what they do, if I need to test double them or not. If I don't need to do, then I don't do it. Another reason why this sort of boundary is interesting is no one can create an aggregate unless it's created by an application service. So there's no way for code to come and new up an aggregate. You cannot take ownership of an aggregate unless you are given one. So you always have to go through the application service to create an aggregate. Maybe the application service needs to go to the repository. It doesn't matter. There's no way for someone to get an aggregate unless it goes through the application service. So I could unit test that as a unit of behavior, but doesn't matter that it goes through more than one class. The same thing is true. So let's see. Oh no, I have before a slide with code. So this is an example of a unit test. So now I'm going inside. If you see, I wrote some unit tests for the controller, and now I'm writing unit tests for the application service. So I'm going from outside to the inside. So I've got some setup, doesn't matter too much. It's the same thing. When I start the exploration of the catacombs, in this case, I'm doing something different. I'm checking that the player repository received save. So when I call start, there's a side effect. And the side effect is that save is called on the repository because we update maybe the room where the player is. So repository needs to save some state change that has happened on the player. And the other example is when you move from one room to the other, there's also so that's the test on the right. So when I call move, I'm also calling the repository and I'm saving that the player has changed room. So it's the same thing. And I still call this a unit test, although it's quite a big thing. It's quite a big chunk of code, but the way I'm building my app, there's no way someone can just create a class that's in the middle of that flow. So I see that as a boundary of testing, and I test at that boundary, and I don't try to go too deep in it and try to, for instance, create test doubles, mocks, or stubs to stub entities or things inside the aggregate. I don't see too much interest or too much advantage in doing that. I see a lot of disadvantages, and one of the big ones is our tests. If we do too fine-grained tests, then it's very difficult to refactor because the tests become a bit too technical and they are too tied to the implementation, and then it makes it difficult when we need to refactor code and things start to break apart. And then maybe the first thing we do is, oh, maybe let's forget about these tests because they are on the way and they are slowing me down. So choosing the boundaries I found it really, really helpful to test at the right place in the boundaries and not worry too much that a unit test is to test a method or to test a class. A unit test is to test a micro behavior. And if that spans more than one class or more than one method, so be it. I'm okay with that. The other unit tests I could write is at the aggregate level. So if you're talking about domain-driven design, I'm not going to go too deep in domain-driven design, but usually if there's an aggregation of classes, they are aggregated because they make sense together. So for me, it doesn't make sense to unit test them individually. So if I need to go test and go deeper and deeper, the next level would be the aggregate. And I probably wouldn't go any deeper unless there's some special case, some very corner case or some special situation where I need to test deeper than the aggregate. The aggregate is where the business invariants rules are applied, and that's usually the minimum level of detail I would go with a unit test. And I'm still calling it a unit test. An aggregate might be quite a few classes and well, entities, value objects, all that stuff. But I tend not to test deeper than this unless it's really required. And that's another boundary of testing. So this would be unit testing, and in here there would be no mocking. So in this case, when I reach the domain and entities and aggregates and value objects, I switch back to the classic school of TDD, and I'm not testing that something is having a side effect on some other class. I'm testing like I test the oven. So when I move a player from room, something happens, and I can assert with state. Okay, I can assert state. I don't need to assert state in the next class. I can assert state on this class. In this case, this class is acting as an aggregate root, which should be the catacomb. I am assuming catacomb has rooms and a map and stuff like that. So let's move on for the next thing. This is a few more examples of unit tests at the same level. So I'm always testing at the aggregate root level, on aggregate level. Again, more moves, still atomic moves. If you remember from the acceptance test, I was exercising like a full tour of the catacomb. And now with unit tests, I'm testing each one of the behaviors. I'm testing that it can move in the different directions. So I'm testing the behaviors in a more micro level. It's still asserting the behaviors. I'm not testing anything about the technical implementation, or try not to. So when I need to refactor and change the structure of the code, the tests are still there to prove because the behavior should be the same. Allow me to do a bit more refactoring. Okay. Oh, So the next bit that I might be interested in testing is the port. If we're talking about hexagonal architecture, would be the ports and adapters. It would be the integration layer, and I still want to test that. I still want to make sure that my repository sends the data to the database and that the database saves the data in the correct format, or in another case that my proxy I have still calls an external service and that the external service receives the data. And I can do that with an integration test. And these tests will be slow, but I probably won't write too many of them. I just want to prove that things are in the right shape. And because I'm isolating that and creating a boundary that's very small, I can still write a few of them and be fairly sure that things are working as I expected without having a slow feedback on the other tests. I accept there's going to be a bit of a slow feedback on these tests, but it gives me the security that I'm testing these things, that the repositories are doing their work. So I keep that in there. The other thing is testing. So I'm testing integration, I say on the right side of the picture. Now I need to test on the left side. So I still want to test that my controller does what it needs to do. And in here, probably I'm going to instantiate my controller from the outside. I'm going to run my application and make an HTTP call to the controller. And then I'm going to exercise quite a bit of code. If possible, I would like these integration tests not to go to the database, because I've already written integration tests for the database and I've paid the price of those tests being a bit slow. So if I can avoid that, then it's better. And one way of doing this is actually not to do the call from the outside. So that's something for you to consider. Sometimes we just write out integration tests. It's always calling from the outside. But if you always call from the outside, then you lose the possibility of mocking or stuffing external resources and make your integration tests slow. So I guess it depends on the scenario. If I have a choice, I prefer to write the integration test from the inside, like I write a unit test. So new up a controller and then fake or test double everything that's external to my application, so that I have a fairly fast integration tests. I'm just testing that the controller is working. I don't need to go test the database because I already have integration tests to test between the repository and the database. So I think I have an example of that. Test doubles. Here's an example of an integration test. And I went to read a bit about this, and on MSDN, I found a lot of documentation, and most of the integration tests were testing from doing a call from the outside. They were making some call to the application, which is fine. It's just that it's slower to execute, and maybe the level of feedback is not great because you have to wait longer for the test to execute. You might have to set up some environment. Even if you do it on your machine, you still have to set up and maintain that environment just to run the integration test. If given a choice and it works, I would prefer to mock the databases and the external services and just test. I'm testing the integration between the controllers and the application, like I'm testing the integration between the application and the database. So I would like to treat it the same way as integration tests on the left or on the right, the same way as much as possible. I know that integration tests starting from the controller will probably do a bit more, but that's fine. I still want to mock away or stop external resource. And so there's an example in here. I'm checking that it returns a 200 OK for some call. Oh, it's the start call. It's the same call. So this is not like the unit test. I'm testing at a bit higher level, but I'm still mocking the outside world. Next thing, this is what I call an end-to-end test. And not just me, lots of people just want to make it more visual and graphical and have these boundaries around. And this is the one I would test really from the outside. But maybe I write very few tests like this because they are very slow to execute. the feedback I get from them, if one test of these fails and gives me a 500, what has failed? Could be the database, could be some configuration, could be some mistake I've made, could be a lot of things. And if I only have these tests to rely on, then I might have to go look into logs or even start debugging the application. I've got nothing against debug, but it's time consuming. And if I have tests only at this level, I'm forced to debug or to look at logs to see why this test failed. And I don't know, it gives me a 500. I have no idea what has failed here. I still think there's value on these tests, mostly to catch configuration issues. But all the rest, we've got acceptance tests at the application level, we've got integration tests, we've got unit tests. Really, the end-to-end, for me, it's there just to test that all the connections are right, all the configuration has been set up. Maybe I could write one or two of them to make sure that the application is all configured and working, and when I deploy, it runs. But I don't need to write a lot of these tests, especially because they are very slow and the feedback is very, very, very high level. Okay, so when we go into this London School of TDD, so back to these two loops of TDD, and if we start from the outside and we write an acceptance test, the problem is it requires a bit more experience from the developer. This is not so much a beginner-friendly approach. Why? Because most of the design decisions happen on the red. So when we were looking at the first slides, we saw, okay, if we're doing the classic TDD, we put all the code in the, let's take it to the absurd. I'm still writing a REST API. I write all the code in the controller. And then as the controller gets messier and messier, I start extracting services and I start extracting the domain. But I've got that mess of code, that feedback telling me, oh, you've got a solid problem in here, you've got a code smell in here. And from that mess of code, I get feedback and I refactor. So I need to be quite good at refactoring if I want to do that extreme approach. If I'm doing the London School and I'm immediately mocking the next one, I need to take that design decision on the red. It's where I take most of the design decisions. So most design decisions on the classic school are on refactor. The most important ones on the London School are on red. So I need to have a good intuition to see if I make this decision, this is going to have as a consequence that this class is going to break, I don't know, open closed principle. So how can I do that? How can I delegate this into a better place so that that open closed violation does not come up? And the same is true for the unit tests. When I'm writing unit tests in the London School approach, I'm also taking most of the design decisions on the red. Okay, so of course you need to have a better intuition for design, because there's the danger in here of creating over engineering, creating the famous factory of the factory of the factory of the factory of the, I don't know, of the command of the strategy and make a big mess. So if you're doing, if I'm working on a domain that I don't know much about, there's a lot of uncertainty and I don't really know how it works, I probably wouldn't approach it using the London School of TDD. I would approach it using the classic approach of TDD, and I would write as much code as possible in the entry point of the application. And once I start to understand how it works, I will refactor that code slowly into a domain. And that gives me a bit more assurance, but it's a slower process. If I understand a bit more the domain, if I have a bit more certainty, then London School would make writing the code faster, because I'm immediately identifying the collaborators and delegating responsibility to them. Next, that's it. I don't know if I'm running out of time, if I went way over time, if there's a lot of time, I can take lots of questions.
Yeah, there's quite some time left. So cool. Thank you, first of all, for a very nice session. Good idea to keep that one up so people can see where they can find some other resources. I
Yes.
do have a couple of questions from the audience here.
Okay. Okay. I like to take
one-
lots of space for questions, so that's good.
All right, let's do that. So first one is, what's the difference you feel between acceptance tests and unit tests?
So in the acceptance test is like it's a bigger piece of behavior. So when I showed the movement, for me an acceptance test would be moving north, moving south, moving east, moving west, doing all the movements. If there's stairs, move up, move down. So I would write an acceptance test that would try to exercise all those behaviors. Maybe take a player on a tour of the dungeon and exercise all those behaviors together. And the unit test would be more, let's try the movement moving north or moving south or moving east or doing something more smaller. I don't know if I'm able to explain this in a way that's understandable. That's how I see an acceptance test. It's a more macro behavior.
Yeah. Makes sense, I think. One that just came in is, what do you feel is a good ratio for lines of functional code versus lines of test code?
Oof, I don't know. I don't tend to think on tests as, I like to think of tests as testing behavior, not testing code. So I don't tend to think on that ratio. I don't know if you're talking about code coverage. Maybe the question implies some sort of code coverage. Code coverage is important, but when it's not when I'm writing new code. It's more when I'm refactoring code that I'm worried about code coverage. Do I have the safety net to change code? Is the coverage good enough for me to tackle this refactor and try to change code? And that's when I see that ratio become more important. When I'm writing new code, I tend not to worry too much about that, to be honest. Maybe I should, but I tend not to. And I tend to write tests that test behavior, not to test functions or to test classes or anything like that. Behavior just happens to be in functions or in classes, right?
All right. Yeah, one question that's probably answered by sending you an email or reaching out on Twitter, but I'm still going to ask it. Do you have any recommended resources that go deeper into outside-in TDD?
Yes. Okay. So there's the I should have had a slide about this. So there's the book about this, which is Growing Object-Oriented Systems Guided by Tests. It was written by Knight Price and Steve Freeman, and that is the big book on the London School of TDD and the outside-in TDD. That's the big resource. It's also known as the Goose Book. But if you search for Growing Object-Oriented Systems Designed by Tests, I think that's the name, you will find it, or search for Nat Price and Steve Friedman, and you will find lots of resources about it.
All right. I think a more practical one is about testing or doing TDD with ASP.NET.
Okay.
A person is having a little bit of issues with how to start writing tests that test the authentication stuff in ASP.NET Core, especially using all of the identity constructs that are in there.
Yeah, I know that writing. So I don't call those unit tests. Sort of unit integration tests, because it goes into the system and reaches out into the depths of ASP.NET, and some of them can be pretty hard to write, especially it's getting better. It's getting much better. So .NET Framework, especially ASP.NET Core, is much more test friendly than it used to be. But there's still challenges in there. There's still lots of challenges on reaching out to the depths and going and test that. I would test that only at the controller level. I would try to avoid, try to isolate as much as possible, because I see that as an integration issue. Even if I write unit tests, it's still an integration issue. It's still something only due with the delivery mechanism. The application is probably isn't aware of authentication. Authentication is done at the borders of the system. So if I can isolate as much as possible, maybe mock everything and stop all the application and all the complexities that go inside, and just worried about the big complexities of authentication and authorization. And it's not an easy place. It's easier now. It used to be a much harder. Microsoft has done a very good job, and the community as well, all contributors. So every time I need to go test these things, I find nice surprises. It's easier. I don't think it's still easy, but yeah, it's getting better.
All right. I find this one a very interesting one, and that is, when do you think that test-driven design is not the way to go?
Oh, many times. Many times. I'm not. I'm talking here about testing a lot and stuff, but I'm not like test obsessed. I like to test. I like to make sure that the applications are correct. But there's lots of ways where you don't want to test. Maybe you're just prototyping some code. Maybe you're spiking something. There's lots of situations where you just want to have a technical feedback, not a behavior feedback. And if you need a technical feedback, probably test-driven development is not the way to go, because it's going to give you a behavior feedback, not a technical feedback. So if I'm sparking some code, if I'm writing some prototype, even if I'm doing TDD, there are lots of times where I need to do technical exploration, like even the code I've shown you. I've written it a few days ago, and some points I would stop test-driven development because I needed to explore. And for maybe 1 hour, I would be exploring how technically am I going to write this. And that way, I was not doing any TDD. I sort of paused TDD. TDD is a tool. It's like a screwdriver. Sometimes you use a screwdriver, sometimes you use a hammer. I tend to use a TDD a lot and test a lot, but it's not always. An exploration is a space where TDD is not very helpful, I think. Or even learning. There's another situation. If I'm learning something, probably TDD is getting in the middle, in the way. It's not about behavior. So those would be some of the situations where I wouldn't use TDD.
Makes sense, I think. Yep. Also from experience, what would you think are the signs that you have enough certainty about your code base and so on, and about the model that you're building to start using outside-in TDD?
Yes, that's a very important question. Yes. So either I know the domain, I understand the domain I'm working on, and I have a deep knowledge of the domain. So I'm fairly certain I understand how it works because of the domain knowledge, or because maybe I don't know so much, but I've got a much better specification. Maybe there's someone that created some architecture design. Maybe the team has agreed on an architecture, on a design. I don't know what the term should be, probably more a design than an architecture. So we've came up with an idea of how we want technically to implement these things. So I already know that the controller is going to call an application service or a use case, and that the use case is going to call, we're using TDD. So the use case is going to call an aggregate, and to load the aggregate into memory is going to bring a repository. So if I have this knowledge, I can start mocking the other things. So when I'm unit testing an application service, I know I can mock the application service or use case, because I know that's what's going to happen. The control is just going to delegate over there. And when I move to the next stage where I'm testing the application service, I'm pretty sure that side effects are going to happen on the database. Or maybe there's some service bus. Maybe you send an event. That's another side effect. I didn't cover that on the code, but that's another side effect you might be interested in covering. You make some changes to an aggregate, and that aggregate sends an event, or the domain service sends an event, however you have events. So if I have those certainties, I'm a bit more confident on using an outside-in London School approach. Outside-in is not the right term, because you can do outside-in with the classicist approach. I like to call it more London School of TDD, where you use mocks a lot to be faster in testing. And it's also interesting because it's this thing about tell, don't ask. You don't expect objects to return stuff so that you can assert. You tell them to do stuff, and there's a side effect maybe on a repository, maybe it sends an event to a bus. And so you're not forced to go and look into the state of an object to see if an operation happens. If I call an application service, I know it's going to have a side effect on a repository, so I can mock the repository and check there. And that way, I'm also leaving a bit more space for design. The tests are not mingled with the design of the application so much. Gives me a bit more freedom to refactor.
All right, thank you.
Is that a fair answer?
Yeah, that's a fair answer. Yep.
Any more questions? Happy to
There's
answer.
a couple of thank yous in Portuguese, so thank you from the audience as well.
Yeah, obrigado.
Maybe let's do one more question, and that is, if you're doing end-to-end testing, would you advise still doing unit tests? Because in the end, you're probably covering most of your code doing the end-to-end tests. So do you still need the unit tests according
That's
to?
That's a great question, because just this morning I was working with a team. It happened just this morning. I said, I'm going to talk this about in the session I'm going to do this afternoon. So we were discussing just this. Should I write a unit test for the controller? Because I already have an end-to-end test for the controller. So they decided against me that they shouldn't write a unit test because they already had an integration test for the controller. I'm fine with that. I'm not like fundamental about. I try to be pragmatic about things, and in there was a fairly good. It was not a very complex controller, so I went along and said, okay, let's do it. Let's not write a unit test for this controller. Let's just test on the outside. And also for this integration test, they went with the idea of let's call it from the outside. So let's invoke it with an HTTP call. And because we already have unit tests at the application services and net aggregates, the controller is so simple, we don't need to unit test that controller. Okay, let's do that. So we wrote the code, we wrote the test, and the test didn't go green. There was a mistake on the mapping. So mapping between the post, the request body, and the data that needs to be sent to the application service was not working. We were also using I think Spring, and there was a version that none of us was very familiar with. So there were a few also technical issues in there. But then what happened is they had to open the debugger, and they had to spend like, I don't know, 10, 15 minutes debugging through the thing until they found the issue. And in the end, I said, why don't we just write a unit test so that the next person does not need to open the debugger if there's a mistake? And actually, if we had written the unit test, we'd have caught this mapping issue very, very fast. We wouldn't have to wait and go debug and waste a lot of time here and get frustrated. So I see a lot of utility in using unit tests, because especially if you use end-to-end tests, the feedback you get is slow and it's very high level. Something has failed. You got a 500 error. What is that? What has failed? Is the repository not working? What is failing in the application? So I don't know. That's a lesson just learned today of me sort of, okay, let's not do a unit test here. And we paid the price. It was not a huge price, but it was more the frustration of we were moving and everybody was sort of, oh, this is not working. Why? And then finally we decided, okay, let's write the unit test so the next person does not have to go through this. If a mapping is wrong, it fails the unit test and it pinpoints that behavior. What's wrong is the mapping between the request body and whatever data structure we need or retrieving that thing. Yeah. So that's sort of my answer.
All right, cool. Yeah, I think most of the questions have dried up. There's a couple of open things that we'll handle on our side. Thanks again for a very interesting session.
Okay.
And yeah,
I tried to recover some time as well. Maybe I went too fast, but
Oh, no, this is perfectly fine. There was good time for questions and a couple of interesting questions giving some additional insight. So perfectly fine.
Okay. Thank you very much, everyone, for attending. If there's a discount for the book, if you want to go grab it.